that you should have done, I don't know if you remember talking about this yesterday, but you should only move stuff that has to go with y. So for example, on this one, I'm only going to move the root h. I'm not going to move the 4. Okay, so one more time, here's y. I can rewrite this like that. And then is it still h stuff multiplied by t stuff?
Yeah.
Okay, so that's better because now, when I move the h, I won't have a 1/4 and then have to cancel it out later. Okay, so from there, go ahead and separate. My root h is going to be on the bottom. My 4t minus 2 is going to stay where it's at. So I'll have 1 over root h dh. And then on the other side, I'll have a 4t minus 2 dt. Then integral. Okay, are either of these sides going to need u sub? No, I can avoid it. Even though this kind of looks like u sub, could I just distribute the 4 in? And then it's not u sub anymore, yeah? So this will be 4t minus 8 dt. Now, before I integrate on the left side, if I have a root h on the bottom, what's that the same as? H to the negative 1/2 because it's on the bottom. Make sense? Okay, so I separate first. I pull my root h up to be a minus 1/2. Then add 1 to this. What are we going to get? Positive 1/2. Then if I divide by 1/2, what am I multiplying by? A 2. Other side, what's the antiderivative of 4t? 4t antiderivative would be 2t squared. And then minus 8 antiderivative is minus 8t plus c. Okay, what would my next step be to get rid of this 2? Divide everything by 2. So I have h to the 1/2. What is h to the 1/2 the same as? Square root h. And then 2 divided by 2 is a t squared. 8 divided by 2 is a 4t. And then c, remember, we just don't care. Okay, so when I divide this c by 2, technically I'm dividing it, but I didn't know what it was, so I just keep calling it c. Then how do I get rid of the square root? Square both sides. And I have my general solution is going to be t squared minus 4t plus c quantity squared. Then I have my ordered pair up here in the corner. Okay, I need to pass through 1, 1, so I'll plug that in. 1 is the answer when I plug in a 1. Okay, then remember just to follow PEMDAS. So 1 squared here is a 1. 1 minus 4 gives me negative 3 plus c. So 1 minus 4 is negative 3 plus c. Then how do I get rid of the squared? Square root. Square root of 1 is just 1. Negative 3 plus c. Stays in the middle. And then add the 3 across. C is 4. So my solution for h would be t squared minus 4t plus 4 quantity squared. And that would be your solution. Make sense? Okay, so there's one question that we skipped before we go on. So, rewind back. I think it's like a page and a half. Yeah. Okay, go ahead and do your separation on number 8. Okay, which is right here. Am I good to take this off or y'all need another minute? Got it? Okay. Okay. So, number 8, first thing that you should notice is that I have y stuff, but are there any x's in that equation? Okay, no. Here's the deal, though. Remember, it doesn't matter if there's already an x, because when I integrate on that side, there will be an x eventually. So, for this one, there's no x right now, but I can just leave the minus 3 on that side, and when I integrate, it will get an x. Okay, so my first step here, I have dy dx equals negative 3 times e to the 2y, And then I'm going to divide that across to the other side. But the negative 3, I'll just kind of leave there to stay on x's side. So I'll have 1 over e to the 2y dy. And then I'll have a negative 3 dx. So I have a 1 over e to the 2y, and then a negative 3 dx. Now, we can integrate this like this, so how are we going to rewrite it? Yeah, I can just take my 2y, I can bring it up and turn it into a negative 2y. Does that make sense? So I'll bring my 2y off the bottom by turning it negative. Now, quick question here. Okay, what method is this side going to need? U sub. Remember, that's like the chain rule, but for integrals. So my u is going to be negative 2y. Do it kind of over here to this side, I guess. Okay, u is negative 2y, then du is negative 2 dy, which means that dy is du over negative 2. Okay, but keep in mind that all of this is for this side. Negative 3 doesn't need anything special. So it'll be the integral of e to the u du over negative 2. And then I can take that negative 2, pull it to the outside. So it'll be negative a half integral e to the u du. What is the integral of e to the u? E to the u again, which is going to turn into an e to the negative 2y when I'm done with it. Okay. Now, notice that that's all this left side. My right side was a negative 3. What's the integral of negative 3? Yeah, just a negative 3x plus c. Okay? And then from there, what would I do next? Multiply by negative 2. So this would cross out. E to the negative 2y would stay. Negative 3 times negative 2 turns that into a positive 6x. C I'm just going to leave alone. Nobody cares. Okay, then your next step, how do I cancel out the e? We need to get y by itself, ln both sides. So I'll ln here, I'll ln here. So those guys are gone. Then I have negative 2y equals ln of 6x plus c. And then my last step, what would I do to get rid of the negative 2 in the front? Good. So I'd have negative a half ln 6x plus c. So remember that the 6 isn't negative because I multiplied a negative 2 on a negative 3. Okay. So your 6 should have turned positive. The other thing too is that remember when you're lning this whole term together. So your c should be inside where the ln is. Okay? And then from there they should have given us an ordered pair. Yeah. Because of the negative 2 right here. So to cancel out and multiply by negative 2, I would have to divide by 2 on both sides. So I'd have a negative half here so that these could cross out. Does that make sense? Okay, so this is my general solution. Now let's do our particular solution. Look up here, it says 0, negative 4. So that means that negative 4 is the answer when I plug in 0. And then in there, what is 2 times 0, or 6 times 0? It would be 0, right? So that'd be 0 plus c, which is just c. How would I get rid of the negative a half? Multiply both sides by negative 2. So negative 2 times negative 4 is a positive 8. My negative half is gone. And if 8 is ln c, then what is c? What do I do? E to the 8. So then c is going to be e to the 8th power. And then I can come back up here to my general solution, plug that number in. So my solution is y equals negative a half ln 6x plus e to the 8. And that's my particular solution. Okay. The next question for this is super important. So, if my equation has a square root, what can the stuff in the square root not be? For a square root, you can't square root a negative. What can you not ln if this is an ln equation? Do you remember? You can't square root negatives. What can you not ln? Negatives or 0. So, when I take the middle of an ln, I don't put greater than or equal to 0. Okay, for a natural log, you would set it just greater than 0. That would be your domain. And then do you remember how to solve those like we talked about? Okay, you'd take the plus e to the 8, you'd minus it across, then divide by 6. So I'd minus e to the 8 across. I'd have 6x greater than negative e to the 8, then divide by 6. Question, would I flip the sign? No, because I didn't divide by a what? Okay, remember, it's only a negative. Okay, so if it's a natural log, you take the middle of it greater than 0. If it's a square root, you take the middle of it greater than or equal to 0. And those are really the only two that they put on the AP test where they'll ask you about domain. Okay. Last one on this part C, we're going to just take the derivative and then move on. How do you take the second derivative of negative 3e to the 2y? If that's your derivative, dy dx equals negative 3e to the 2y, what would the second derivative be? What's the derivative of e to the 2y? E to the 2y times what? 2 dy dx. Do you remember why? Okay, if your equation has a y in it, 2y, the derivative is 2 dy dx. And then what happens with the negative 3 and the 2? Negative 6. And so I'd have negative 6 e to the 2y. And then my dy dx, I can leave it like that. Or do you remember that you can take the equation and sub it in for that as well? Now, you would have to do that if it says these words right here. In terms of x and y means I can't leave a dy dx. So the only thing that I would have to change is I would say, okay, well then that's the same as negative 6 e to the 2y, negative 3 e to the 2y. And do you see the difference? Okay, this is regular. This is in terms of x and y. That means only x's and y's, and then obviously numbers are allowed. Make sense? Okay. So you should have picked up notes for today. Did you pick them up? Yeah. Okay, we're going to get into some science today. Are you excited? Oh, great. Okay, as much as I would love to do all of this, I'm just going to kind of pick a few of them to give you an idea. So I want you to take your notes that are right here. Okay, and I want you to go ahead and, actually we have to do just the very beginning on the first page before we skip. So look at the top. Do you remember what proportional means? Okay, sort of, yeah. So if I were to tell you your height and your arm span are proportional, what does that mean? Yeah, like the taller you are, the longer your arms are. What about the shorter you are? Shorter your arms. Okay, or if I were to say the size of your hand and the size of your foot, the bigger your hand is, probably the bigger your foot is. That's what proportional means. So, proportional functions have what's called a constant of proportionality. And it's the ratio that everybody shares. Okay, now obviously with people being tall, some tall people have little feet. It's not perfect. Okay, but a proportional relationship means that you have a constant ratio. So, for example, and then the letter that they usually use for that is K. So if you'll put like a little K right there. Okay, that is the model that you would normally be talking about. So take a look at this first one. It says, the gallons of gas consumed by a car is proportional to the number of miles traveled. That means that your gas is whatever your proportional number is times n. So if I increase the number of miles I travel, what's going to happen to the number of gallons I use? Going to go up. What if I decrease the number of miles I travel? It'll go down. Okay, so look at the next one. The rate of change of the area of a polygon. Okay, well that would be dA dt. That would be dA dt. Okay, then it says the rate of change of area is proportional to, that's my K, proportional to what? Square root of a side S. Okay, you get the idea? Okay, next one. The rate of change of a population, that would be dP dt. The rate of change of the population is proportional to, that's my K, the cube of the population, so that would be population cubed. Does that make sense? So proportional means you're going to take whatever you have and multiply it by a constant K. All right, last one. This one's a little bit weird, but maybe you'll remember. Water leaks out of a barrel at a rate proportional to the square root of the water remaining in the barrel. How would you measure water in a barrel? Volume, which is cubic. So you would say dV dt is proportional to, and then it says the square root of the water left, so that would be the square root of the volume. Okay? So the point is that if it says proportional, you put a K next to what it's proportional to. Okay? So, turn to the example that we were going to start at. Okay, turn your paper over. I might. I'll check. I want you to set up an equation for number 4. Okay, so read through it. We're going to use the letter P for population. So just read the beginning, see if you can set up an equation. Okay, number 4. Yes. Okay, so it says, the population of bald-faced hornets is growing at a rate, what would I put for how fast the population of hornets is growing? dP dt. Okay, because it's how fast it's growing, it's a rate, okay? Then it says it's proportional to, what do I put? K, proportional to what? Population, which is P. Okay, this is a separable differential equation, okay? So, P is my Y, T is my X. Where am I going to move P if I need to separate it? Okay, so to the left side on the bottom. So it's 1 over P dP. And then my K is going to stay on the other side with a dt. Good so far? Integrate both sides. What's the integral of 1 over P? ln P. What's the integral of K, which is a constant? Just a constant we don't know. What do we call it? Kx, but instead of an x, I'm going to use a t plus c. How would I get P by itself if it's inside an ln? E both sides. So I have absolute value of P equals e to the kt plus c. Okay, real quick little algebra 2 review. because this is a weird thing the AP test always does, and I'm just going to explain it today, and then from now on we're just going to do it. Okay, if I have e to the kt plus c, that is the same as e to the kt times e to the c. Agree or disagree? Okay, that's a rule from Algebra 2, that if I'm multiplying bases, I can add the exponents, right? Okay, now remember, c is a number I don't know. So if I put in a number I don't know on top of an e, is that still a number I don't know? Yes, then I'm going to rewrite this as ce to the kt. Okay, the reason why is this is a number that I don't know, so I'm just going to move it in front of the e. And from now on, whenever you have a plus c up here in your exponent, you're just going to bloop, put it right here. Now, here's why that's a better place for c. How do I get rid of absolute value bars? Do you remember from yesterday? You put a plus or minus. But if my c is here, I don't know what it is. Could it be plus or minus? Yes, then I'll have to put it. Does that make sense? So my population is ce to the kt. Does that look familiar from Algebra 2? Yes? Somewhat? Okay. So now let's keep reading, and we're going to need to figure out the information to know what we need to solve. It says on May 1st there were 10 hornets. Okay, so at time 0 there were 10 hornets. And then it says in 30 days the population had grown to be 50 hornets. That is enough information for me to figure out what C and K are. Okay, and you should have done this in Algebra 2, but I know that it's been a minute since that happened. So, the first thing that I'm going to do is I'm going to use my point with a 0 in it. The reason why is that's the easier one. So, look right here, we're plugging into this guy. I'm going to say my time and my population. My population is 10 when my time is 0. Well, what's K times 0? What's e to the 0? 1. Then what's C? C is 10. Yeah? So now what's my equation? Instead of CE to the KT, now I know that it's 10E. Oops, that's a P. 10E to the KT. So far, so good? That is a P. Okay, so far, so good? So the first point helps me find the first letter. Now I'm going to use the second point to help me find the K. So we have this information. Now we need to use this guy. At time 30 days,